Day 818 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3014, minimum number of pushes to type word 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string word containing distinct lowercase English letters. Telephone keypads have keys mapped with distinct collections of lowercase English letters which can be used to form words by pushing them. For example, the key 2 is mapped with ABC. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type the word after remapping the keys. An example of mapping of letters to keys on the telephone keypad is given below. Note that 1 star or 1 asterisk, pound, and 0 do not map to any letters. So let's take a look. This is an example of a telephone keypad, and as you can see right here, we have 3 letters on each of these keys right here. And if we want to tap A, we press 2 once. If we want to tap B, we tap 2 twice. If we want to tap C, we tap 2 3 times. That's what it's talking about right here. So boom, now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, in example 1, our input word equals a string A, B, C, D, E. Now, it's important to remember that this keypad does not look like this keypad, right? So this has A, F, G at 2, and this has A, B, C at 2. Similarly, in example 2, the keypad looks different too, so I just wanted to point that out. But as we continue, the output is 5. The explanation says the remap keypad is given in the image below provides the minimum cost. So we push A. For A, we push 1 time on 2. So we push 2 right here to get A. Boom. So that's how we got. That's 1 push. Then to get B, we push 1 time on 3. That's a 2nd push. Boom. Then on C, we press 4 1 time, that's a 3rd push. Then on D, we press 5 1 time, that's a 5th push. Or excuse me, that's a 4th push. And then finally, we press E on 6 1 time, and that is a 5th push. Now, the keys are arranged like this because, remember, we want to find the minimum number of times keys can be typed into a string, and it says right here, telephone keypads have keys mapped to distinct letters. Hold on. Oh, right here it says it is allowed to remap the keys number 2 to 9 to distinct collection of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. So this right here is just a remapping of the letters to allow us to get the minimum amount of pushes. If we want the minimum amount of pushes with this string, we need to have A, B, C, D, E, all on different numbers, right? So we only have to push a number once, because if we had to push a number twice, say we had to push, say it was like this, right? And we had to push A once, then we had to push twice to get to B. We already had 3 pushes, and then to get to C, we had to push 3 more pushes. So that would take 6 pushes in total just to get A, B, C, right? So that's why we had to remap this telephone grid so that each A, B, C, D, E are all on different numbers, so that we only have to push them once. Boom. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, our input word equals a string X, Y, C, D, E, F, G, H, I, J. This time the output is 12. The explanation says the remap keypad given in the image provides the minimum cost. So this is the remap keypad that gives us the minimum cost. We push X, push 2 once, and we get X. Boom. Then when we want y, we have to push 2 twice, right? So because x comes before y on 2, so we push 2 twice and we get y. Boom. And then right now we're at 3 pushes. Boom. Then we push c once. We push 3 once to get c. Boom. So that's our next push. Then to get d, that's going to take 2 pushes once again like it did over here. So 1, 2. So that's 2 more pushes. So right now we're at 6 pushes on D. Now we're on E. Boom. That takes 1 push. Boom. Now we're on F. F takes 1 push as well. Boom. Now we're on G. G takes 1 push. Boom. Now we're on H. On 7, 1 push. Boom. Now we're on I. Right here on 8. That's 1 push. And then finally, we need this J, push 9 one time. And in total, that took 12 pushes to get this string right here after remapping the telephone grid. Boom. So now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. And guess what, y'all? Guess what? We got 2 solutions today, so make sure you stick around to the end so you can get the second solution. Now, for this first solution, the first thing we want to do is we're going to create a variable that stores the frequency of each lowercase letter. So we're going to come right here, declare a variable called char freak, set that equal to an array, open up the parentheses, we're going to say repeating, colon 0, comma, count, colon 26. Boom. Now we need to count how many times each character appears in Word. So we'll come underneath this and we'll say for char code in word.utf8. We'll open up the brackets and we're going to say char freaks, square bracket, int, open up the parentheses, char code minus 97. Come outside of all of this and we're going to say plus equals 1. Boom. Now we're going to sort frequencies from largest to smallest to the most common letters receive the fewest button presses. So we'll come underneath this and we'll say char freaks dot sort, open up the parentheses by colon greater than. Then we need the total number of key presses required. So we'll come underneath this, declare a variable called ands, and set that equal to 0. Now we're going to assign characters to keypad positions. The first 8 most frequent letters require 1 press, the next 8 require 2 presses, the next 8 require 3 presses, and the final 2 require 4 presses. So we're going to say for, open up the parentheses, I, comma, freak. Come outside of that, say in char freaks dot enumerated. We're going to put a parentheses and we're going to open up the brackets. And once we reach a frequency of 0, there are no more letters in the word, so we can stop. So we're going to say if freak equals 0, we're going to open up the brackets and we're going to say break. Boom. Now, we need to multiply the number of presses by the character's frequency since every occurrence of that letter must be typed. So we're going to come underneath this and we're going to say ands plus equals freak times, open up the parentheses, 1 plus I divided by 8. Boom. Now we need to return the minimum total number of key presses by coming right here. And we can say return ands, y'all, just like that. Let's give it a run. Make sure it runs properly before we submit it. Ooh, okay, let's see. So we got the wrong answer, so that means somewhere the math is not mathing. So right here, this should be ands plus equals, y'all, not equal. So now let's run it again and see if that fixed it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, matter of fact, actually, I forgot to show y'all, we got another code. We have another solution. So let's go ahead and get into this second solution. And guess what, y'all? Guess what? This solution is only one line of code. We got a one-liner. So let's get into it. It should be quick. So all we're going to do is we're going to come right here. We're going to open up the brackets. We're going to open up the parentheses. We're going to say $0 divided by 8 plus 1. Come outside of those parentheses. We're going to say times, open up some more parentheses. We're going to say $0 minus $0 divided by 8 times 4. Then we're going to come outside of these brackets and we are going to open up some parentheses and we're going to say w.count. Boom. Oh, sorry, maybe this should be word.count. Sorry. Let's give it a run. See if that did the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.